turn itself off. Let's zoom in. I like that idea a lot, Richie. So I'm going to take the measurements, which are the test scores in this case. I'm going to put them in a column. I'm going to call it X. And we're going to scratch them down. Ernie's got an 82. He's got an 81. He's got an 83, I think. 79 and an 80. Okay. We're going to make this formal. We're going to make this formal and orderly at least once. At least once. Because while we're learning about this idea, it isn't the most clear idea, I don't think. And you'll see why momentarily. Okay. Where does Carolyn's consistency versus inconsistency come from now with respect to the average? What can we do? Don't overthink the math. There's not much math to do. What do you think? If I'm going to compare these data points to their average, what can I do?
Plot them together.
How about subtracting them? Take the average away from each one and see how far it is. Kind of like we just did with, look at that quiz, the quiz question we were looking at. We did the 0.3 minus 26, 0.3 minus 27. Let's do, so I'm going to make a new column here. Okay, X, which is the data point, minus X bar, which is the average, the sample average of their scores. Now that looks a little bit cryptic, but that's all it is. It's the difference of the data point and the average. Okay? So 82 would be 82 minus 81, or 1, which would tell us what? What is the 1?
There's 1 above the average score.
Exactly. That particular test score is 1 point above average. That's all that tells us. It's one. If you're thinking about units, it's 1 point. That particular test score is 1 point above average. 1 point above average. That's all that tells us. And by itself, that's meaningless right now. By itself, that's pretty meaningless. I want to come back to why we don't look at that by itself momentarily. How about 81? What's that going to be?
0.
There's no deviation at all from that one. He landed at the average in that case. Which with discrete data you can do sometimes. Sometimes. Not often, but sometimes. Let's keep it going. 83. Love it. Positive 2, so we're 2 above. 2. Oh, good, good. Thank you for the unit. 2 points above. Very good, very good. 79. Love it. Oh, negative 2, right?
Or -2.
That's 2 below. 80 is going to be -1, isn't it? Yeah. Good. Excellent. So what we now have is we now have a set of 5 values, 1 for each data point, 1 for each data point, that tells us how each data point varies from the average. Yay! That makes me happy. Because that's great. That's a great thing to know. The bigger the numbers, and when I say bigger the numbers, I also mean conversely the smaller the numbers, the further away they are, the closer to 0, the more well, the closer to 0, the closer to average. The further from 0, the further the average. Beautiful. I want to go one step further, of course. I want one number that stands for the entire data set's consistency or inconsistency. Remember how we had an average? The idea of an average or a median or a mode, the idea of that was to take an entire data set and give one number that talked about its center. I now want this entire new data set, if you will, this entire data set right here, I want one number to talk about its spread.
0.
0 spread? How'd you get 0, Carolyn?
Well, it's basically the median in there.
Oh! So find the median of that? Excellent. Fine. So Ernie has no variation because the median is 0. Excellent. Excellent. I got no problem with that at all. Let's go back to Bert real quick. Real quick, if it'd be okay with you guys. Go back to Bert real quick. Real quick. Let's do the same thing for him. So real quick, conversationally, where would Bert's median of variation be? Which of his heads up on the screen?
82.
82, right? It's got to be because they're in order. All right. So Bert's right here. Good. 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 Very good. Very good. His median of variation, it would be 1 point above average. Can anybody think of a small problem with looking at just the median of the data sets?
Just because it says if he's 1 point above average and Ernie's only average, it says that he's better than
Well,
average.
my complaint is it says they're essentially back to being the same again. Because 1 and 0 are so close to each other. Because the problem with the median in this case, Carol, thank you for this, by the way. The problem with median, Laura, in this case, and I love what you said quantifiably, now Bert is better even, 81.3 is bigger than 81, 82 is bigger than 81, and 1's bigger than 0. But my problem with that is they're not big enough to be meaningful. And I want to come back, that's kind of what this whole course is about is, well then how big is big enough to be meaningful? And I apologize to push that back for momentarily, but your point is well taken. My problem is, if I use a median, I lose the other 4 data points as if they're not important anymore. And here's the problem, Averages use every single data point and their values. Medians use every single data point and only their positions. So if we choose to use the median on those 5 numbers and the median on Bert's 5 numbers, we then lose the fact that his lowest is a 61 and his lowest is only a 79. They are just the lowest. And we lose how much lower Bert's is than Ernie's. Is that a fair assessment? Nothing wrong with your logic. I think we get away from what we want though, which is a quantifier on how to deal with all 5 of those points. So if the median doesn't work, do we have a mode? No, mode's out. What else can we try? You can average them. Can we average those? Of course. What does it average to? Careful, average the variations. Average the things in that blue rectangle. What if we average the things in that blue rectangle? You get 0. Once again, there's no variation. Crap. Let's go back to Bert. Back to Bert. Hang on. Crap. Back to Bert. Okay. Somebody write down these numbers. We're going to figure out some variations on the fly here. 61 from 81 is negative 20, right? Okay, negative 20. 60.
13, 1, 13, and 19.
Thank you, Austin. Total friggin' Austin. So you have negative 20, negative 13, yes? Negative 13, 1, 13,
19.
and 19.
Well, they're close. But
Average them.
Comes out to 0 again.
They average just to 0 again?
Yeah.
Well, here's the unfortunate news. It will always average to 0. It doesn't matter what data set you have. This is one of the most interesting, I think, concepts in this course. If you take any data set, no matter how big it is, no matter how many, how few, you calculate that data set's average, and you set up this list like we just did, no matter how big or how small that data set is. If you add all of these things up, it will always add to 0. Who just said that? Who said why? I offer it as extra credit in your variation homework. And I'll be more than happy. It's actually much easier to prove than you think. If you look at it symbolically, it's a very, very clever algebraic reason as to why they have to. Essentially, here's an explanation non-algebraically. Average is a balance point. Average is where, if you were balancing cookies on a tray, it's where you have to put your finger to balance the tray, yes? So, essentially, what it says is, the same amount of weight has to be on that side as that side to balance. Now that's a clever cookie on a tray with a finger kind of explanation. It doesn't explain it mathematically. So, if anybody wants to give it a shot for extra credit, I've got it explained in the variation homework. Give it a whirl. I'll leave that open the entire class. Very few people try it though. But give it a shot if you want to. If you're curious without getting the points, come by the office. I'm more than happy to show it to you sometime. It's actually really, really cool. It's like a 5-step, not even 3-step proof as to why it is. But it doesn't help us right now because we're screwed. Because we can't use that data set alone.